Subramanya Chandrasekhar. Imagine a young man, just 19 years old, standing on the deck of a ship. The endless ocean stretches to the horizon, mirroring the infinite expanse of the night sky above. He is leaving his home in India, bound for the hallowed halls of Cambridge University. But his most important discovery won't happen in a lecture hall or a lab. It will happen right here, in the quiet solitude of this voyage, as he holds a question in his mind so profound it could unravel the very fate of the cosmos. What happens to a star when it dies? That young man was Subramanya Chandrasekhar, and the answer he found on that ship would change astronomy forever. Born in 1910 in Lahore, Chandrasekhar was a prodigy, a nephew of Nobel laureate C.V. Raman. His brilliant mind for mathematics was evident from the start. His academic journey led him to Presidency College in Chennai and then to that fateful voyage to England. And it was on that journey that he conceived the Chandrasekhar limit, a concept that is now a cornerstone of modern astrophysics. So, what is it? Picture a star like our sun after it has burned all its fuel. For smaller stars, the end is required determined as a white dwarf, an incredibly dense Earth-sized cinder. But Chandrasekhar asked, is there a limit? He calculated that there is a point of no return, 1.4 times the mass of our sun. He theorized that if a dying star is heavier than us, its gravity will be too powerful. It cannot become a stable white dwarf. Instead, it must collapse catastrophically, destined for a far more spectacular end, a supernova, leaving behind a neutron star or even collapsing into the infinite density of a black hole. This was a revolutionary idea, and it was met with fierce skepticism from the scientific establishment, including his own mentor, the great Sir Arthur Eddington. But Chandrasekhar, with quiet confidence, stood by his math. His perseverance was vindicated over 5 decades later when he was awarded the 1983 Nobel Prize in Physics for this seminal work. Chandrasekhar's journey didn't end there. He moved to the University of Chicago in 1937, where he spent decades shaping the world of science. His brilliance flowed into numerous fields. In radiative transfer, he penned the equations that describe how light travels through stars, work that remains essential today. He explored hydrodynamic stability, studying the complex flows of fluids and astrophysical objects. And in his years later, he turned his genius to the mysterious elegance of Einstein's theory of relativity, producing masterpiece works on black holes. But beyond the theorems and equations was a man of profound humility and dedication. A mentor to generations of scientists, he once said, "The pursuit of science is a fusion of the spiritual and the intellectual." His legacy is not just a number, the 1.4 solar masses that bears his name. It is the enduring inspiration that a single mind, curious and courageous enough to question the universe, can indeed discover its deepest truths.
And perhaps in some way, that initial assumption, the initial dedication to science has remained with me all through the years.